Hey guys, it's Andre from High Performance Academy. Welcome along to this week's webinar. Today we're going to be talking about the differences between what we consider to be a club level wiring harness and those that are more traditionally referred to as mil-spec. We don't really like using that term, and instead we prefer to refer to them as professional motorsport wiring harnesses. So we're going to talk about some of the differences in terms of the materials used, why different materials and techniques are used for professional versus club level, what you're going to be looking at in terms of required tooling or equipment, consumables, cost, time, all of those sorts of things, and finally answering the question as to how you should choose between one or the other in terms of the techniques you're going to be using. Before we do that though, we're just going to cover off a few things that have been going on, and it is a busy week here at HPA Labs because it is race week. This week we have the second round of our endurance championship, so that's practice on Friday at our home track Highlands Motorsport Park, followed by qualifying and a 1 hour endurance race on Saturday. And then to just add a little bit more motorsport into our weekend, on Sunday we've got the first round of the Highlands Sprint Series. So those are a series of, I think we get 4 6-lap races on a shortened version of Highlands Motorsport Park. So pretty excited. I'm going to show you a few other things that have been going on with preparation for the two cars. Before we get into that, just because it is pretty much on point with our discussion today, our webinar today on motorsport wiring, I just wanted to jump across to my laptop screen and show this is an Instagram I put up late last week, and this is also relevant because the video that I'm going to show you today that we just launched on our YouTube, it features this particular steering wheel. So one of the things we quite often end up with in motorsport is a situation where we've got a lot of driver controls fitted to the steering wheel. For those who have been following us, I did talk a couple of weeks ago about the buttons and switches we've just fitted to the steering wheel on our Toyota 86, and one of the problems is getting all of these controls back through to the ECU. And the traditional method is to use a curly cord running from the steering wheel back to the chassis. In this case, Mercedes AMG here with their DTM car have used a very special quick release steering hub, and this is from Crontech, and this actually incorporates essentially an Autosport connector inside the steering wheel itself. There's obviously the matching part of that on the steering column side of the adapter, and essentially then this allows you to quickly connect and disconnect all of your wiring from your switches, etc., as soon as the steering wheel is removed. So it means that you don't have one of those curly cords in the way. Of course, everything comes at a price, and considering this does incorporate two sides of an Autosport connector, you can understand that these aren't the cheapest devices in the world. Now, on that note as well, I should say, it is still likely, even though with all the controls that are on this AMG steering wheel, that probably somewhere up in here, I'm only really spitballing here, but I'm just going to take an educated guess, the team are probably using an analog to CAN interface board, because you're going to need a sensor 0 volt and a digital input for each of your switches. For an analog voltage input, or a potentiometer multi-position switch, you're going to need a 5 volt reference, an analog voltage output, and a sensor ground. So understandably, by the time you've got a few of these controls plus some paddles there for shifting and the clutch, etc., there's a lot going on, and you've got to get all those wires back through. Now yes, you can do this with an Autosport connector a little bit easier than you can with a curly cord. However, chances are they're probably using this CAN interface board. So what that does is it takes all of the wiring on the steering wheel and it converts the digital switches and the analog voltage potentiometers into a CAN message, and this means that the actual wiring that runs between the steering wheel and the chassis generally only needs to be 4 wires. We're going to have a 12 volt, a 0 volt, CAN high and CAN low. So it greatly simplifies everything. Now, if you are considering jumping out and purchasing one of these pretty expensive Crontech hubs, I just mention though that they are still really designed primarily for purpose-built race cars, where you're going to have a limited amount of steering lock as well, because obviously even at the chassis side, you've still got to get your wiring out of that steering column. So if you've got a traditional factory style road car where you might have 3 turns lock to lock, you're still going to end up wrapping up the end of that cord at the column end. So just a little bit of insight into some of the techniques that are available when it comes to steering wheel switch controls for professional motorsport. Now, just getting into some of the things that have been going on with the preparation for our Toyota 86 for this weekend's round of the Endurance Championship. So we'll head across to my laptop laptop screen. And Brandon has been busy getting in some late nights and some long hours setting up a little bit of basic aero on the car. Now, we're not talking here about anything that has any computational fluid dynamics involved. We're not aerodynamicists. This is just designed to be a quick and dirty attempt to get us just a little bit of downforce at both the front and the rear of the car. So this is pretty common at grassroots motorsport levels. So we're being pretty honest about exactly what this car is and where it's intended. At some point in the future, we do plan on developing a slightly more sophisticated aero package for the car, plus wide body. But for the moment, we're getting by with a sheet of 12mm plywood. That's what's made our splitter there. So we've just extended that out to help try and control the airflow both above and below the car. And while it's a little hard to see here on the side, Brandon's also incorporated a canard and an end plate. So we weren't really super keen on the look with plywood though, so to make it look a little bit more race car, he has gone to the trouble of laying that up with a carbon Kevlar and epoxy, so it does look just a little bit better than it would normally. So you can see that canard sitting in there. So we're hoping that that will give us a little bit more grip at the front end, and to go along with that, we've also incorporated a rear wing. Now again, this is just a relatively cheap off-the-shelf rear wing. There's not a lot of data available for it, but we're kind of going with the principle here that some is going to be better than none. And at the last round, I'm pretty confident we were the only car in the field that had absolutely no aero, no rear wing at all, and it kind of looked on the starting grid like we'd got lost on our way to the spectator car park. So we're hoping that that will work, particularly at our home track. We know the track very well. We know what the car's capable of, and there are some really high-speed corners where we're kind of limited on our traction. So we're hoping that just a little bit of downforce is going to help us out there. Now, the other thing that has been going on with that car, since we put our TTI 6-speed sequential gearbox in it, we have obviously had to make a drive shaft to suit that. So we had a company make a drive shaft for us. It's a one-piece drive shaft. It uses a slip yoke at the front, and we've been chasing an imbalance, or a high-speed vibration, I should say, ever since that went in. Now, it can be a little bit hard to track down these high-speed vibrations because we changed a lot of components all at the same time. We obviously fitted the 6-speed sequential gearbox. We also had the drive shaft made. We also did some work on the rear differential, and it had new axles in the back. So what we're really facing here, and for those of you who haven't experienced this, it can be really off-putting. Like, this is a serious vibration. When you get into 6th gear, the vibration in the car is so bad that it's difficult to see out of the rear view mirror, which is not that helpful when you've got GT3 race cars coming up behind you at high speed. And it's also not really that good for the components in the car. So far, we've had that high-speed vibration cause a power feed off our alternator to fracture. We've also had the bracket for our alternator fracture, and we sheared through a bolt on the front of the drive shaft at our last race. So obviously, we want to get on top of this, and we haven't been sitting on our hands here. The first step was to send the drive shaft back to the company that made it. They checked the balance, found that the balance was out, supposedly corrected it, sent it back, and it was absolutely no better. So we kind of decided we needed a more rock solid solution. Dealing with my sort of network of contacts in New Zealand here, found out who another race car builder here in New Zealand that I trust was using for drive shafts, a company in the North Island of New Zealand. Sent the drive shaft up there. They checked the balance on the existing shaft and found it was out by a massive 20 grams. So at this point, we've had them rebalance our initial drive shaft. We've got it back in the car. Obviously, we're going to be crossing our fingers and hoping on Friday that when we get out to test that the high-speed vibration has gone. At the same time, we also have just received our new drive shaft shop 1,000 horsepower rear axles. Probably overkill for what we're doing at the moment, but this will future-proof the car for what we've got planned. Now, the limitation with the factory hubs in terms of how big we can go on the drive shafts, or the CVs is really the limit, is the size of the wheel bearing and where it goes through the hub. So it kind of limits the drive flange size, which in turn limits the outside outside diameter of the spline. So basically with 1,000 horsepower axles, drive shaft shop go to the trouble of supplying a complete new hub assembly, a bigger wheel bearing and a bigger drive flange. So those will be going into the car as well. Now if we just jump back across to my laptop screen, now this won't be making it into the car for this next round, but when we purchased the car, it had a set of endless front brakes which work exceptionally well. This was matched to a set of stock rear brakes which are a cast iron one-piece rotor and hat, and we were finding that while it wasn't suffering from any problems with the braking, if we looked at the temperature using brake temperature paint on those rear rotors, we were getting up to somewhere in the region of 550 degrees C, which is pretty high, not outside of the working range of the pad. So as I say, the braking wasn't a problem, but what we were having issues with was our outer CVs were getting exceptionally hot to the point the grease was melting through the CV boots, and we were having failures with the outer CVs. So one of the theories that we worked on, and this is just a theory, was that we were putting a lot of heat, obviously 550 C, going into the hub through that one-piece brake rotor, and there it's going to end up getting transferred to the outer CV as well. So at the moment we've put the rear brakes off our other car, which are a two-piece rotor, much bigger with a 4-pot caliper. Ultimately though, we're going to be making up a new set of rotors and a mounting hat for these endless brakes. So that takes us through to the modifications. I just want to also talk about the repairs that were necessary after our last round. And for those who joined us last week, I showed a short video of us getting shunted in the back of the car coming into turn 1 on the first lap. Not ideal, and it actually ended up doing a reasonable amount of damage. Panel-wise, there was a little bit of work required there to straighten things out. But awkwardly, as we can see here, or as you probably can't see, but the area I'm circling there, this is where an external surge tank and fuel pump was mounted by the original person who built the car. Now, remembering that this was originally built as a street car, probably in hindsight, not the smartest location for a fuel pump in a race car. And we're going to be addressing that ultimately with a new bash bar that's actually going to wrap right the way around the entire rear of the car. However, in this accident, what it did is it dislodged that surge tank a little bit and pushed it forward. And I'll just show, there's a side shot of that surge tank system. And what we ended up finding was during Ben's stint, he got in about halfway through our 1 hour race. And just towards the end of my 1 hour race, I was starting to get driver warnings for a low fuel pressure and the car was starting to surge. I thought that was just because the fuel level was low. We only had about 11 litres left in the tank. Came in, did our pit stop, put another 40 litres in to top it off, and Ben headed out. And on his outlap was already complaining about fuel surge. So that didn't really make a lot of sense. Looking at the data, we were seeing anywhere from 4 bar, which is the normal fuel pressure, down to as low as 1.5 bar. So obviously not great. What we ended up tracking that down to, or Brandon has just got on top of, is that when the pump was forced forward, it was ending up sitting against another part of the chassis that it should have been well clear of, and the positive feed to the fuel pump was resting against quite a sharp piece of steel. So when the car went around a corner, that was actually shorting. So this is fed power via a ECU Master PMU, and this is kind of one of those mixed blessings because the PMU is set to fuse every circuit, and we can control the fusing current as well as how many times the unit will retry a particular circuit if it does blow that fuse. And what was happening here is it was set to basically indefinitely retry the fuel pump circuit. It would blow that fuse, it would wait 1 second before reinstating power. So this is what was causing our fuel surge. So ultimately we're going to get on top of that anyway, and we'll be ready for this round of the championship. Now, as I mentioned, we've got 2 cars racing this weekend, though. We've also got our Racecraft Toyota 86, which is our original development car. Those who are familiar with it from a little while ago would remember it was a white car fitted with the FA20 engine with a turbo kit on it. So we've just gone through and we've fitted a whole lot of new suspension components. In the back here we can see we've got our SPL parts, CNC machined alloy suspension arms. We've also got a set of MCA coilover suspension there, as well as MCA's little traction mod bracket, which affects the anti-squat geometry at the rear of the car. At the same time, we also took the opportunity to fit up a set of Hankook slicks, which we had lying around for a fair while. So this is the first time the car's actually run on slicks. Now, part of this was because we were filming the worked example for our racecraft course. So for those who aren't familiar with racecraft, I'll just quickly mention that racecraft is our offshoot project we're about to release. So essentially identical to High Performance Academy. However, this will be focused on race driver education, car modification, basically how to optimize your car if you're attending track days and you want to get a little bit more speed out of the car. And our very first course is on do-it-yourself wheel alignments. And this is a skill that I reckon every home enthusiast who is interested in track days should have. And it's really not that difficult to do, and it's not going to require you to spend the earth in terms of components. So here we've got the car set up in our workshop, and we're using what's referred to as a string wheel alignment system. So we've got a frame at the front and the rear of the car, and that holds these alloy bars. And what we've basically got is two alloy bars, front and rear, with machine slots in them that we can then, might be a little bit tricky to see, we can then locate a string down each side of the car. The aim there with those strings is that we want those strings to be parallel to each other as well as parallel to the center line of the car. Once we've done that, we can very easily and accurately measure the toe at both ends of the car, as well as measuring our camber using a camber gauge caster as well if you want to measure that. So it allows you to make very quick changes to the suspension setup, and particularly you can then do this at the track. Really useful, particularly if you want to try improving the performance of the car, the handling of the car, or even if you want to change between a dry and a wet setup. So really excited to have that course out. We've just finished proofing it this morning, a couple of small changes that are needed, and we're hoping that that course will be out in the next few days. So if you are interested, you'll be able to check that out at racecrafthq.com. For all of our existing HPA members, you're going to get some email information about that when it is released. All of our existing HPA VIPs are also going to get free access to that course. So pretty excited to get that out there. Now, on top of the wheel alignment settings, looks like I've run out of photos. Just bear with me for a second here and I'll try and get them up. Right, on top of the wheel alignment settings, it's also one of our sort of aims is to always run our cars on the dyno, because that way we know that, before we head to a race meeting. This way we've got the confidence that when we get to the race meeting, unload the car off the trailer, we're going to know that on the outlap we're going to have no problems, or at least that's the plan. So we want to basically eliminate any chance of problems creeping in that we could have dealt with before we get to a race meeting. So that's exactly what I did with the racecraft car last night. Got it loaded up on our mainline Pro Hub dyno. And just for those who aren't aware, the engine combination here is a stock standard FA20 with a set of BC aftermarket connecting rods, HKS head gaskets and ARP head studs. So very basic engine setup. We've had no problems with the factory cast pistons, even though they are 12.5 to 1 and we're running a turbo kit on it. It is an AVO turbo kit, although we have swapped out the original AVO turbo in favour of a Borg-Warner EFR 6758. Still one of my favourite turbos for a street application on a 2-litre engine. And on 0.85 bar of boost peak, we ended up with 394 horsepower at the rear wheel. So that's the most power it's ever had. One of the changes that we made prior to this meeting was to fit our Tomei titanium exhaust system, which is a little bit more free-flowing than what's normally on it, but also a little bit louder. And for those who are wondering how we get away with that much power on a 12.5 to 1 naturally aspirated engine, it's of course because we are running on a diet of E85. So everything in that car is also controlled by a Motec M150 ECU. So pretty excited to get that out on the track for the Sprint Series and see how it goes, put it through its paces and check the performance of all of that new suspension gear. Right, moving on, we have also just released our latest video, which is our Tuesday release. So we'll just head across to my laptop screen, and if you haven't seen it already, please make sure you head across to our YouTube channel and check it out. So while we were at Goodwood Festival of Speed, we had the opportunity to check out a wide range of amazing cars. One of my favourites was this 2018 Mercedes Amg Dtm C63, and this is a series that I haven't followed in too much detail. Always admired these cars, particularly the Aero component of the cars. They really are impressive from an Aero standpoint, but never really got a chance to get too up close and personal, particularly considering we're on the opposite side of the world. So it was great to find out what actually goes into these cars, in particular finding out about the control chassis. So in this case, it runs a carbon fiber monocoque. It's actually really not that far away from the sort of technology used at the likes of F1 level, and there is a control chassis regardless what the actual body on the car is. Of course, all of the bodywork is then adapted to that carbon monocoque chassis, and the bodywork is made out of carbon fiber as well. So while they may look loosely like a Mercedes Amg C63, there's really not a lot of C63 left in the car. So if you're interested in learning a little bit more about DTM technology, then head over to our YouTube channel, check that out and subscribe. And pretty happy to announce as well, we have just clocked over 100,000 subscribers. So it's been a long uphill battle. We do thank you all for subscribing and supporting us, those who are. We do get a lot of positive feedback from our channel. Of course, we're trying to put out technical content that is really appealing to a niche market. We're not really in the market of trying to put out mainstream videos. So probably not much chance that our videos are going to be clocking over 3 or 4 million views like some of the more popular channels, but we like to think that we bring something pretty special to the table, and from the feedback we get, it sounds like it is pretty well received. Last but certainly not least, we are running another one of our giveaways, and this particular giveaway we have teamed up with the guys from JE Pistons in the US. Got just one sample here, which is for a Porsche from memory, but JE are well renowned for making some of the best forged pistons out there. We've run them in a number of our own engines, including our old drag engines for our Mitsubishi Evo drag car. So JE will be giving away a set of their shelf stock pistons, and along with that we are also including our suite of engine building packages so that you're going to know what to do with those pistons. So if you're at a point in your own project where you're considering an engine build, then this is the ideal opportunity to perhaps jump in and score yourself a free set. They're going to be giving away anything as long as it is one of their shelf stock supported products. So basically, if you're dealing with a mainstream engine that's popular, chances are they've got you covered there. So our suite of engine building courses includes our engine building fundamentals, our engine building practical course, as well as our how to degree a cam course. On top of that, you're also going to get access to our private members only community, which is the perfect place to ask questions on your specific engine building project. So I'll get the team to drop a link in the comments that you can follow if you want to get your name into the draw there. There is, of course, absolutely no cost getting involved there, and you'll find that there are a few additional steps that you can take that'll give you more entries into the draw. So head across and make sure you sign up. That has only just recently gone live, so it's got a little way to go, but make sure you jump on that while it's still fresh in your mind. All right, thanks for watching there. Give me a few moments and we'll get started with today's webinar.